Geometry students, pretty short video. We will have an activity tomorrow to show how some of these things work. To show that you watched the video, I better see every slide written down so you can pause them. As you're reviewing for your quiz tomorrow and you're looking through some of the proofs that we've done, notice that we have the definition of congruent triangles, which I like by the other name CPCTC, which stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. I will probably use CPCTC from now on instead of definition of congruent triangles. But to prove two triangles congruent, which we've done a couple times, we've always had to use the definition of congruent triangles, which means all three sides are congruent to the corresponding sides, and all three angles are congruent to the corresponding angles. Nelson knows from a previous class of some shortcuts, and some of you may know of some shortcuts, and today we're going to talk about the shortcuts. What are some faster ways to get triangles congruent? First one we're going to study is called the side-side-side congruence postulate. Remember, postulate means we do not prove this to be true, we just accept it as true. And it says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if you can get two triangles where you know AB is congruent to RS, and BC is congruent to ST, and AC is congruent to RT, then you can say triangle ABC is congruent to RST, and in that order. Order matters. You will lose points in this class on proofs if your proof statements are out of order. So if you want to prove ABC congruent to RST, you better make sure that in your steps above it's always AB on the left and RS on the right and BC on the left and ST on the right and CA on the left and TR on the right. Or if you say TR is congruent to CA, you use the symmetric property to flip it in another step. You will lose points for being out of order. Not a significant amount of points, but they add up if it's consistently wrong throughout your proof. Side is a beautiful shortcut. If you can get three sides of a triangle congruent if you can get three sides of a triangle congruent to three sides of another, then you can just say the triangles are congruent by side. Good. One area where you might see this in geometry is what if we have a equilateral quadrilateral. So an equilateral quadrilateral is called a rhombus. It's where all four sides are congruent. Well, then I can easily just put in a diagonal here, say that diagonal is congruent to itself, and then what I can prove is that because these two triangles are congruent to each other by side, I can prove that this angle is congruent to this angle. And if I do that, I have AIA congruent, so I know these sides are parallel. I can do the same things with the other angles here, and again, I get two other sides being parallel. And so just by saying you have a quadrilateral that's equilateral, you now know that it is a parallelogram, which is powerful. So side is going to be nice. We get a lot of theorems in later geometry courses from later geometry chapters by getting triangles congruent. Another shortcut is called the side angle side shortcut, SAS. This one is very important as well. And it's also important that you get the order in which it's named. It's called side angle side because if you look at the picture of the triangle, you know the side and another side and the angle between them. So the angle is between the two sides that you know are congruent. So a lot of kids will make this mistake where they'll have something like this: side and angle and side. but then in the other triangle, they'll have this information. Because the angle here is congruent to this angle here, but it's not the same necessarily as the angle between the sides, you can't use side angle side. Notice side angle side is also a postulate. It is not something that we can prove to be true. Has to go in this order. If you pick what you know a side, and if you go counterclockwise around, it goes side, angle, side. Same thing if you started here. You would go side, angle, side, side, angle, side. So order really matters. Good? Gotta have that. Now, the next theorem, and it is a theorem, can only be used with right triangles because they are the only triangles that have hypotenuse, sides, and legs. And this one says if you have the hypotenuse of one triangle congruent to the hypotenuse of another right triangle, and the side here is congruent to the side here, then we know the two triangles are congruent. The only reason this works is we know that a squared plus b squared equals c squared for all right triangles. So if I told you that one of these was the same, the hypotenuse was the same for two right triangles, and one of the legs was the same for the two right triangles, it's pretty easy to show algebraically that the third side would also be the same. And then you could say the two triangles are congruent by side, side, side. It's nice when you know that you have a right triangle. Remember, how are you going to know you have a right triangle? One of the angles in the triangle is a right triangle. How are you going to know if that's the case? Well, I'll probably tell you something's perpendicular to something, so then in your proof you'll have to say because it's perpendicular, then I know it's a right angle. Because I know it's a right angle, I know this is a right triangle. Now that I know I have a right triangle with a hypotenuse congruent to another hypotenuse and a leg congruent to another leg, I can say those two right triangles are congruent by hypotenuse leg. All right, short video. You're lucky. Study for your quiz. In geometry, the quiz topics that you will see tomorrow are two pictures using exterior angle theorem, third angle theorem, opposite angles of a right triangle are complementary. I might throw in some parallel line here just to give you some alternate interior angle practice or something like that. And then, that should be this way. And then finding what this is because you know it's complementary. Might give you what this is and ask you what these two are. Remember that the exterior angle is the sum of the two non-adjacent interior angles. You could also just do that the linear pair theorem, and these are supplementary. So you'll get two pictures like that. And then on your second topic, you will have a proof. And I may or may not have you reorder it, right? So I might give you like a bank of statements and reasons that you need to put into the proof. Or it might be fill in the reason or fill in the statement given a reason. Or it might be completely blank. So be ready for your proof. All right, have a great night. Peace.